Okay, question number 8. Calculate the number of mole of the sodium chloride. Okay, look at to the question. We have 50 ml of the lead nitrate stock solution. It is diluted to 250 ml volumetric flask. Okay, and then 25 ml of the dilute PbNO32 is then reacted with 80 ml of the sodium chloride. Okay, so the first question, calculate the number of mole of the sodium chloride. So sodium chloride dia dah bagi volume dengan concentration. Okay, so kira mole. So N is equal to M multiply with V, so that the molarity is 0.2 multiply with 0.2 mole per liter. Molarity kan mole per liter kan. Multiply with the volume is 0.08 liter, so that you will get the mole of the sodium chloride is 0.016 mole. Okay. And then what is the concentration of the diluted lead nitrate? So you have to understand the process. Mula-mula kita ada PbNO3 tu yang concentrate, yang stock. Stock ni maksudnya pekat. Okay, and then dia dilute kan. Okay, it is undergo dilution to produce PbNO32 yang dilute lah, yang less concentrate. Okay, and then dia dilute kan sebanyak 250 ml. Okay, asal-asalnya stock solution ni ada 50 ml saja. So dia dah cairkan jadi 250 ml. Okay, and then daripada 250 ml lead nitrate ni, yang dilute ni, dia cuma guna 25 ml. Okay, only 25 ml that is used to react with the NaCl. Okay, and then the amount of the NaCl that is used to react with the lead nitrate 25 ml ni is what we have calculated here lah. It is 0.016 mole. Okay, so if you want to know what is the concentration of the PbNO32, okay, since that it is to know the concentration is by the process that we know as a reaction. Okay, we want to know the concentration of this from the information that we have in sodium chloride, and they are reacted. So we have to use the second equation, which is MAVA. Kita tak guna M1V1. M1V1 is for the dilution. Dilution kita guna untuk dua proses ni. Okay, but from NaCl punya amount, we want to know what is the concentration of this. We are using MAVA equation. Okay, so to use the MAVA equation, we already have the ratio. Okay, so the equation will be MAVA. Saya terus guna N lah. MAVA, M multiply with V is actually equal to N lah. N of the NaCl over N of the PbNO32 is equal to M NaCl V NaCl over M molarity of the PbNO32 V for PbNO32 is equal to A over B tu is 2 over 1. Okay, so we have calculate the mole of the NaCl. So yang ini ni, yang atas ni dah solve. Okay, from the equation we also know that volume of the PbNO3 that is used ni is 25 ml. Okay, A dengan B pun dah solve. So kita cuma nak dapatkan what is this molarity of the lead nitrate. Okay, so kali ni kita terus je guna the the mole of the sodium chloride that we have used lah, that we have calculated. Okay, so make this as the subject. Okay, so M of the PbNO3 is equal to ni naik atas. So it is equal to mole of the sodium chloride 0.016 mole. Multiply with 1 ni, silang naik atas kan. Okay, and then over volume 0.025 liter multiply with 2. Ni, 2 ni, A ni turun bawah. Okay, so that we will get the concentration will be 0.32 molar. Okay, so this is the concentration of the diluted lead nitrate. Okay, and then see, we have to calculate the molarity of the stock solution. Okay, so the concentration here is 0.32 molar. Okay, so we want to know what is the molarity of the stock solution. Okay, so we have to use the dilution punya equation. M1V1 equal to M2V2. So we want to determine what is M1. So M1 is equal to M2V2 over V1. Molarity of the dilute solution is 0.32 molar. Multiply with the volume. Okay, berapa volume yang dihasilkan? Bukan berapa volume yang kita react kan. Masa kita dilute tu, kita dilute sampai berapa banyak. Okay, so it is multiply with 0.25 liter because it produced 250 ml. Okay, and then divide with volume 1 is 0.05 liter, which is this 50 ml. Okay, and then we just press the calculator, we will get the initial concentration is 1.6 molar. To the information that we have lead nitrate solution 25 ml, 0.052 molar. Okay, and then we have the second lead nitrate 25 ml with other concentration 0.125 molar. They are different concentration. If we mix these two solutions, okay, they come from two different container. For example, we have two different container. I have the concentrated one, which is 0.125 molar, 25 ml, and then the dilute one, 25 ml juga, 0.052 molar. Okay, and then these two container, then I mix them. Saya campurkan. So when I mix them, it means that their concentration now changes. Okay, because they are dissolved in each other. Okay, and you have to calculate the new concentration after they have mixed. So the clue is, if you want to know what is the new concentration, okay, molarity final, you have to know what is the, because molarity is always mole over V. Okay, it means that you have to know what is the mole final over V final. Lepas dah tambah dua-dua tu. Okay, berapa mole solute final? Means that you have to calculate how many mole of the solute in this 25 ml 0.052 molar. Dapatkan berapa mole lead nitrate. Tambahkan dengan how many mole of the solute lead nitrate present in the second bottle, second container, and then you get the total mole. N1 plus dengan N2 over volume 1 plus dengan volume 2. Okay. And then you will get the new concentration after you mix them. Okay, so I want you to answer this question first on your own. Okay, question number 10. We have antacid 1.25 gram and then it is dissolved in 500 ml. Calculate the molarity. So it is a simple question. So question number 10, you just need to calculate the number of mole and then divide it with the volume 0.5 liter. So you will get the molarity is 0.0298 molar. Okay, we have acetone. Okay, look at to the information that we have. We have acetone. Okay, it is made by adding 35 ml of, they produce a nail polish remover. Okay, so this nail polish remover solution is made, okay, by adding 35 ml of the acetone that have a density of this with 50 ml of the ethyl alcohol with the density of 0.789 gram per ml. Okay, so dia tambah dua solution ni. Satu acetone and another one is the ethyl alcohol. 35 ml, 50 ml with different density of course. Okay, so the question want us to calculate the percentage mass, the percentage mass weight over weight of the acetone. So we have to know the formula first. Okay, so percentage W over W means that the mass of the, since that soalan nak acetone kan, so that percentage dia akan jadi gram of acetone over gram total, which is acetone plus dengan ethyl alcohol lah. Okay, so to get this, to calculate percentage W over W, we have to know what is the mass of the acetone first. Okay, so the mass of the acetone will be equal to dia punya volume 35 ml ni multiply with the density is 0.79 gram per ml over ini jawapan yang atas ni. Okay, 35 ml multiply with 0.79 gram per ml plus dengan the second one which is 50 ml multiply with the density 0.789 gram per ml. Multiply with 100%. Okay, so the mass of the acetone, okay, gram of the acetone here, atas ni, we will get the mass of the acetone is 27.69 gram. Okay, and then the mass of the ethyl alcohol is 39.45. This side is 39.45. Here is 27.65. Okay, ni jawapan lepas dah darab lah kan. Multiply with 100. So that we will get the percentage mass is 41.2%. Okay. And then the next one is question B. The question want us to calculate the molality. So molality is equal to mole of solute over kg solvent. Yes. Okay, so mole of the solute, resulting solution is acetone. Solute kita in this case is the, in this case our solute is acetone lah kan, sebab soalan A tu daripada atas tu dia tanya acetone. Okay, so solute kita acetone. From the mass we can recalculate the mole. Okay, kita dapat berat dia 27.65 dekat atas ni, kira mole dulu. Okay, 27.65 gram. Okay, divide with its molar mass which is 58.09 gram per mole. Then we will get the number of mole of solute. Okay, divide with the volume, the mass of the solvent. Okay, and then the mass of solvent this time is the ethyl alcohol 39.45 ni. Ini ethyl alcohol will be the solvent. Ini solvent. Okay, and then acetone is the solute. Okay, so we dissolve acetone. We dissolve acetone in the ethyl alcohol. So that kg of the solvent, we have 50 ml multiply with the punya density. So we have the mass of this 39.45 turn to, or convert it to kg, 0.03945 kg. Okay, so we will get the molality is 12.1 molal. Okay, and then calculate the percentage volume by volume. Okay, so volume will be V of the, ni paling senang lah. V of the acetone. Oh, tapi dia nak volume of the ethyl alcohol. Okay, so that V of the ethyl alcohol over V total. Okay, so V ethyl alcohol tadi is 50 ml. Divide with 50 plus dengan 35. Multiply with the 100%. So that the V over V volume is 58.8%. Okay, and then the concentration in ppm. Okay, so concentration of the ppm is the mass of the solute in gram over mass of the solution multiply with 10 exponent 6 ppm tu. Mass solute over mass solution multiply 10 power of 6. Biasa kan kita multiply 100 kan? 100% to get percentage. So to get ppm, dia macam dapatkan percentage juga. But instead of multiply with 100, we multiply it with 10 exponent 6. Okay, so that it will be, okay, solute kita just now is the acetone, which is 27.65 gram over the concentration of the mass of the solution is 27.65. Solute plus dengan mass of the solvent is 39.45. Sebenarnya kita guna balik ni je yang kita kira berat asal tadi. Okay, multiply with 10 power of 6. Okay, so we will get 4.12 times 10 power of 5 ppm. Okay, ppm is part per million. Normally it is used to determine the concentration of a very so dilute, okay, the substance or the species that is present, okay, with a very minimal amount. Okay, sangat dilute, sangat sedikit. Okay, bila kita guna ppm, contohnya when we want to determine how much mercury in a cosmetic sample. Okay, mercury is a heavy metal kan? Okay, we will never calculate the concentration of the mercury in the cosmetic sample by using molarity unit. Okay, because we will use molarity, that is when we have a large amount of the solute. Okay, but if we have a very minute amount of the substance, okay, or trace amount, contohnya macam berapa banyak iron Fe in a sample of leaf, okay, dalam sampel daun, kan very dilute kan. So kita, it is not, we are not going to use molarity ke, then we are using ppm. Okay, ataupun we want to know how much lead in a fuel kan, because normally when we go to the petrol station, dia akan cakap unleaded fuel kan. But sometimes when we do the research, okay, we analyze the fuel sample, they are still presence of the lead Pb, okay, in that fuel. Okay, but very minute amount. So kita akan guna ppm unit pada masa tu. Kita akan guna molarity ke apa ke. So ppm, ppb part per billion, part per million. This is for a very dilute solute, okay, in our sample. Okay, that is why we still need to know what is the ppm lah, walaupun kita jarang guna in our lab lah. Okay. So question number 12. 12A. Simple je kan? We have 5 molar of lithium sulfate. Okay, is added to 1.6 liter of water. Okay, kita tak tahu berapa volume of the lithium sulfate 5 molar ni. Okay, katakanlah X liter of the lithium sulfate, okay, with the concentration of 5 molar. It is then being added to 160, 160 ml of water lah. Maksudnya, volume asal adalah X. Okay, this is volume, initial and also the concentration lah is 5 molar. And then final will be X tambah dengan 0.16 liter. Okay, and then it will form 0.3 molar. Okay, the new concentration is 0.3 molar. Initial concentration is 5 molar. Okay, initial volume we don't know. Okay, but the final volume is initial yang kita tak tahu tu plus dengan 0.16 because it is added to 0.16 liter of water. Okay, and you have to calculate the molarity of the Li plus ion. Okay, so firstly you have to calculate the molarity of the solution lithium sulfate ni. Okay, berapa concentration? Sekejap to form 0.3. Oh, actually to answer this question, you have to know that in one lithium sulfate, Li2SO4, we will have 2 Li plus and 1 SO4, 2 minus. Okay, so if you have 1 molar of lithium sulfate, you will have 2 molar of Li plus and 1 molar of sulfate ion. Okay, so if you have to calculate the molarity of the Li plus in the solution that have a 0.3 molar of lithium sulfate, so kalau 0.3 molar, maksudnya it will be 0.6 molar lah. That's the answer. Okay. Tapi this is the method lah. This is the simplest method. But somehow the answer, the marks is 8. Okay. The answer scheme gave us a long way to get it. Okay. Disuruh kira concentration, sepatutnya itu je lah 0.6 molar. You got the same answer? Ke tak buat lagi?
Yes, dapat 0.59.
0.59 tu you buat macam mana? Itu you solve X dulu. Ke?
Cari volume dulu. Guna M1V1 equals to M2V2.
Okay, lepas tu?
Cari dia punya number of mole, lepas tu buat mole ratio.
Boleh jugalah. Itu long way lah sebab tu markah dia 8. Okay, you solve you punya X ni dulu. Okay, by using M1V1, M2V2. Okay, and then calculate mole. And after mole, you use the ratio. In 1 lithium sulfate, we have, if 1 mole of lithium sulfate that we have 2 mole of Li plus and 1 mole of the sulfate ion. Okay, so that's the idea lah. Solve X to get the volume. by using M1 V1 M2 V2 equation. Okay, and then you calculate the mole of the lithium sulfate, right? Li2SO4. And then the third one, you calculate the mole of Li plus. Okay, from the mole of the Li plus, you calculate the concentration of the Li plus. Okay. Okay, next is potassium phosphate. Okay, we have 3.5 molar of potassium phosphate. It is added to 0.21 liter of water to form 0.7 molar of potassium phosphate. It means that this is the dilution process. Calculate the molarity of the potassium ion K+. Okay, it is the same as lithium question. Okay, sama macam ni. Okay, it is actually the dilution process. We have a initial and also final. Okay, we know that initial M1 V1 is equal to M2 V2. Okay, and then initial volume we don't know. So M1 we don't know, but V1 we don't know. Okay, but we know that M1 is 3.5 molar multiplied with V1 is equal to V1 plus dengan it is added to 0.21 liter. Sama juga case dia. Okay, 0.21 liter multiply dengan dia punya V2. Sorry, this is V2 actually. Multiply dengan concentration 0.7 molar. Okay, so you solve your V1. Okay, and then you are using the mole ratio. In 1 K3PO4, we will have 3 mole of K plus and also 1 mole of the PO4, 3 minus. Okay, so that if you have 1 molar, this one will be 3 molar, this one will be 1 molar. 1 mole, 3 mole, 1 mole. If we have 5 of this, means that we will have 15 of the K plus and 5 of the phosphate ion. Okay, please use the ratio to solve this. Okay, so that is the idea. So I hope that you can complete question 12. Okay, so as possible don't use my saya punya shortcut ni. Okay, please use the long journey. Okay, you have to solve what is the volume first, then get the mole and of the LiSO4, and then the lithium ion, and get the concentration of the Li plus. Same goes with this. Okay, and I want to remind you, please answer the last question in the last video. Okay, ada satu soalan dekat dalam video yang terakhir tu. Hujung sekali tu. Please try to answer that lah. Okay, so kita akan discuss mula the answer for question 12 ni. And then question 9. Kan? 9 tak discuss lagi. Okay, 9D. Okay, 9D dengan 12. Okay, ada soalan tak?
Madam.
Yes.
Yang 12B tu jawapan akhir dia 2.1 kan?
B. Ya.
Okay.
Kalau kita tengok pun 0.7 ni kan? If we have 0.7 molar of the potassium phosphate, so that K plus concentration will be times 3 lah. 2.1 molar. Okay.